Hello there, and thanks for stopping by this new video. In this video, we're going to be learning about factors that impact climate, and we're going to focus on elevation and the orographic effect. Before we dive into that, let's do a quick recap of what we've learned so far from the climate unit. First, we established that climate is the average weather condition of a region over a long period of time, usually decades. Climate is different from weather. Weather is the minute by minute or hour by hour or day by day atmospheric condition we see throughout outside our window. Climate, on the other hand, is an overarching average of the weather condition over a long period of time over a much wider geographical location. And then we looked at factors that impact climate, and the first factor that we considered was latitude. And then we said with the concept of latitude, the earth is divided into climatic zones, and we looked at those climatic zones. We focused on three climatic zones. The first one is the tropical zone, which is the region right around the equator, hot all year round, high amounts of precipitation, high humidity. The weather is hot all year round. They have two seasons basically. And then we talked about the polar region or the polar zone, aka the frigid zone, and that zone has very low humidity, low evaporation, low precipitation, and therefore low vegetation, and forest technically is a frozen desert. And then we talked about the temperate zone, and the temperate zone is sandwich in between the tropical zone and the polar zone. We have one in the northern hemisphere and one in the southern hemisphere, and that this part of the earth experience 4 seasons in alternating pattern, which means when the northern hemisphere is experiencing winter, the temperate zone in the southern hemisphere will be experiencing the opposite of winter, which will be the summer. All right, and then we did a nice wrap up on that. So this is the way, in this way, latitude influences how the climate of this region or this part of the earth will behave. Also take note of your important lines of latitude. You have your equator, the Tropic of Cancer, and then the Arctic Circle, and then the North Pole. Below the equator you have the Tropic of Capricorn, the Atlantic Circle, and then the South Pole. Also note their degrees, the numbers attached to those numbers, very important. You're gonna need them as we move along. So today we're going to be diving into the next factor that influences climate, which is elevation. Another word of saying elevation is altitude, which simply means height. And then from there we're going to move on to the orographic effect. Simply put, as one goes higher and higher and higher within the troposphere, where we have the weather, where you and I will live, the first layer of the atmosphere, the troposphere. Within the troposphere, the higher you go, the cooler it becomes, which means temperature decreases as altitude or height increases. So if you're at sea level, for instance, this is data from somewhere in Scotland. At sea level is 10 degrees Celsius. So as you go higher above sea level, 200 meters above sea level, the temperature drops by 2 degrees Celsius. And then as you move up another 200 meters, the temperature drops to 6 degrees Celsius. And then upward, it gets colder and colder and colder, such that by the time you get to the mountaintop, it's technically below zero. And that is negative 2 degrees Celsius and negative 3 degrees Celsius. For these reasons, when you look at the pictures of most mountains, the tip or the peak of the mountains are usually glaciated. They have glaciers or they are frozen because of this low temperature as one increase in altitude. Remember your Earth Science reference table, page 14, and then we discussed that within the troposphere, as one goes higher from sea level, the temperature is decreasing from 15 degrees Celsius and decreases all the way to negative 55 degrees Celsius. Also, we also established that pressure decreases as you go higher away from the Earth's surface. So the higher you go, the lesser the pressure. The higher you go, the cooler the temperature within the troposphere. So we're going to bring all those ideas into what we are learning today when it comes to climate and altitude or height. So simply put, the higher you go up a mountain or a high elevation from sea level, the cooler is going to be. The rule of thumb here is that it gets about 6.5 degrees Celsius for every 1,000 meters. So the higher you go, the cooler it becomes. That's it. Easy breezy. Let's look at these two questions here. Question number 1 says, which climate factor is responsible for the snow seen on Mount Kilimanjaro? Mount Kilimanjaro is in Tanzania in Africa, which is technically a tropical country. It's supposed to be hot all year round. However, on top of the mountain, Mount Kilimanjaro is the highest mountain in Africa. So on the top of Kilimanjaro is frozen. So the question is asking, why do we see snow or why do we see glacier on the peak or on top of this mountain? Of course, the reason is simple. The high elevation. Not the high latitude. If it was high latitude, then we are looking at the 90 degrees latitude, which is around the pole or the North Pole or the South Pole. So this has nothing to do with latitude, but rather it has something to do with elevation. So our correct answer here would be B. Question number 2. Which graph best represents the general effect? The general effect that differences in elevation above sea level have on average annual temperature. So as you go above sea level, what happens to temperature? That is what it's asking you. And we established that from our ESRT here. The higher you go, the cooler it should be. So as altitude increases, temperature should be decreasing. And that is an inverse relationship, an indirect relationship. And we expect the curve of that kind of relationship to be downward and slopey downward. All right? It's not going to be upward and forward. It's not going to be consistent. It's not going to go up and then go down. No, none of those wouldn't work. Here it will be option C here, which means that when temperatures are low, elevation would be elevations. When temperature is very high, elevation will be very low as well. And then when temperature is very low, elevations will be very high. So take note of that. Let's move on to the orographic effect. Simply put, as wind comes from the ocean and then they meet a mountain, all right, the wind is forced to go up. So as the wind is forced to go up, remember, the higher you go, the cooler it becomes. Since this wind is coming from the ocean, it has a lot of moisture in it. And as it goes higher and higher, the temperature begins to cool it down. All right, the higher you go, the cooler it becomes. And then the higher you go, the pressure decreases. If you remember what we learned about pressure system, there are two pressure systems. You have the high pressure system and the low pressure system. High pressure system, you experience a very bright weather, very sunny weather. Low pressure system, a very gloomy, slow, wet weather. So as pressure decreases and temperature increases, the water vapor in the air is forced to cool and condense, and thereby creating precipitation on one side of the mountain. Then, by the time the air gets to the peak, all the moisture has been condensed out of it. So what goes to the other end would be a very free, moisture deficient air. So the air that gets to the peak of the mountain and starts going down, that air lacks moisture and is dry. So as a result, it descends, and then the lower you go, the hotter it becomes. So this temperature, this air moving downward is dry and it gets warmer. So as a result, this side of the mountain is dry and kind of desert-like, because it doesn't get rain, it doesn't get any moisture, it doesn't get any cool air, so it's dry. So we call that part of the mountain the rain shadow region. Rain shadow, which means the rain did not get there. All right, let's quickly recap that again. Wind comes from the ocean with a lot of moisture, and the wind is forced to move up the mountain. And as a result of that upward movement, it condenses and forms the cloud. And then the clouds leads to rain on that side of the mountain. And then by the time the wind gets to the opposite side, the moisture is out, is deficient of moisture, is dry. And as a result, you have a desert-like scenario being created on the other side of the mountain. So this will be a nice recap. The side that the wind is coming from with the moisture is called the windward side. And then the side or opposite side that doesn't get the rain is called the leeward side. This is the rain shadow side. So remember, clouds and condensation and rain occurs only on one side of the mountain, usually the side of the mountain that the wind with moisture is coming from. And then the opposite side is hot, dry, moisture deficient, and you have the desert-like effect taking place there. And then we call that the leeward side. So let's wrap it up by reviewing two questions. Question number 3 here says, compared to the climate of location A, the climate of location B is most likely. Now, if you look at the diagram, you have location A here and location B here, and you have the prevailing wind direction coming from the side of the mountain. So this means this is the windward side, and this is the side that will have a lot of moisture, a lot of condensation, and a lot of rainfall. And side B will be the side that will be dry and desert-like. So it's asking us how location B would be like. So location B, would it be cooler or wetter? And wetter, definitely not wet. So option A is out. Option B, cooler and drier. Drier, yes, but not cooler. It should be hot because the air that is coming down, when the air is coming downward, the lower you go, the hotter it becomes. The higher you go, the cooler. The lower you go, the hotter. So take note of that. Option C, the warmer and wetter. Definitely not wet. Our correct answer here will be D, warmer and drier. And last question here, and we'll wrap it up. The climate of location A is more humid than location B because A is So let's look at location A here and use location B here, and then we see that this symbol, according to the map, represents mountains, and we're talking about elevation and orographic effect today. So we see that our location A is on the windward side because it's closer to the ocean. This is where they said that the wind is going to blow from with moisture. So the side A would have more moisture, more condensation, and more rainfall compared to B, which is on the opposite side, the leeward side of the mountain. So location B definitely would be drier. So it says the climate of location A is more humid than location B because A is at a lower elevation. No. B would also be at a lower elevation as well because it's at the foot of the mountain. B says at a higher latitude. Both A and B are around the same latitude. They are both in United States, so they are right around the same latitude. C, on the side of the mountain range facing the prevailing wind. Yes, location A is on the side of the mountain facing the prevailing wind. Yeah, and that would be the reason why it will be more humid. It will have more moisture. Yeah, our option here will be C. Just to be sure, let's look at option D. Receiving a greater amount of energy from the sun. No, both A and B are right around the same part of the earth, so they should be receiving equal amount of energy from the sun. Gentlemen, ladies, we're going to wrap it up here for this video. I'll see you in the next one. Bye for now.